Sharing my screen. Okay. So just a quick introduction. I'm seeing that some other people or maybe new joining has there joined there. Okay. So maybe this is not the first class for this session. This is almost the end class. So this is the hot topic for today. I mean, we have included that one as a basic for this crash course for from this session only. Maybe from the next session onward, we should be having some hands on top of Hadoop. Okay, that was not possible for a hands-on or software installation for this session. So maybe you can also join the existing one. You can also join for the next session when we'll be learning Hadoop with the hands-on experience. Okay, so today we'll be teaching Hadoop as a big data tool. Okay, so it's totally high level knowledge should be there. And tomorrow I'll be going ahead with some detailing stuffs. I mean, for in Hadoop or in a particular big data technology, there are various tools have been used. Okay, but we'll be just introducing what kind of tools are there and how people can get accustomed of one of the tool, or they can have the expertise of one of the tool, or you can have the experience over there, or I mean, you can take your job by having experience of one or multiple tools on big data. Okay, that is possible also. And tomorrow we'll be picking up one tool with having some more details. So that should be covered up in tomorrow's session. But whoever just joined for this classes, I mean, this is the first class of yours, then that should be difficult for you. So I'll be expect you to join the next, I mean, beginning of the next session. That should be next Monday. Okay. Okay, fine. Getting started with Hadoop. Okay. So first of all, what is Hadoop? Hadoop, it's a open source software platform. And why will be requiring Hadoop? So it's having the capability of distributed storage. So for storage, I mean, if we are storing large file or anything, just like this, we can split the thing, we can distribute the thing with multiple memories. That's why it's called distributed storage. And there is another thing that is called distributed processing. So multiple, I mean, for the processing as well, I mean, for compute power, we need compute power for processing some data. So that thing can also be distributed in nature. So if you distribute the thing, the work will be very much simple and it will be much faster than the conventional one. If we are doing with a single machine or anything. Okay. So that is why Hadoop brings this control to make our life faster. If we have millions or billions of records available, okay, and that should be processed within a minute. If this is the scenario, then this is the best approach. We can distribute the storage spaces as well as we can distribute the processing, compute processing. What should a computational power required for a particular system to do? That can be segregated between multiple machines and the work can be easily completed. Okay, so this is the main concept of Hadoop, and that is why we are, I mean, working or we can handle big data. Big data means we have millions of record. Okay, in a table. So suppose we have a table or we have a, I mean, we have a database that stored multiple lines of column, multiple rows, multiple columns, and the transaction is very fast as well. Maybe daily basis we are receiving that one, this many rows. So to operate on top of that one, to have the transformation, to have particular ETL logic implemented on that. So that thing should be controlled by Hadoop. Otherwise, it will take, I mean, much more time to load the data. Maybe that kind of millions of records by a simple ETL tool without using big data or Hadoop technology over there. We can we can see that it is taking 4 hours or 5 hours of time to be completed. If we use Hadoop, definitely it should be 100 times faster. Okay, so that's why the concept is distributing the data as well as the computing power. between several machines. That is why Hadoop is in place now, and it's a one of the hot topic in the big data solution part. Okay, so this is that particular picture. I think you might have seen in anywhere in any poster or anything. So this is called Hadoop ecosystem. Okay, so Hadoop is built such a way. There's a long history. If you are interested for what is the history, who has invented the thing, and which is the present company owning this one. Apache is the present company, of course, and I mean how it's getting invented and all. So you can get in touch with web search and all. So you can see the below three. The at the bottommost there's HDFS, Hadoop Distributed File System. This is the basic building block. On top of that, there's Yarn. I'll tell you which of the block, what is this, especially these three. Okay, these three are inbuilt block of Hadoop. And on the top, there is MapReduce. Okay, so these three will help us with distributing the data and everything and all. The other thing you can see, those are add-on features of Hadoop. It should be there, it should not be there. It's an extension. Those are, I mean, making Hadoop also much more efficient as well. Okay, just like there is Pig. Pig is working on top of MapReduce. So Pig is getting help for all of this component from Hadoop, and it is having some another user interface. Okay, sorry. Just like Hive. Hive is having some SQL interface. On top of MapReduce, whatever data we are storing over here, even HDFS and all, okay, we can point our interface on top of that and we can prepare SQL query. SQL start from a table. The table is not an table over there. The table is a file stored in HDFS. So Hive can, I mean that in Hive, whatever we are doing the query, we are doing select star from table, and the table is not a, I mean table exactly, it's a file over there. Pointing a file, you can convert into a tabular structure, just like data frame, creating from an external file. So this kind of quick data, conversation over here, we can go ahead with this kind of component. Each of the, building block is very much important. Just like Tez, you can see Hive is ended over here, but Tez is ended over here. That means Tej is having the MapReduce platform inbuilt in it. So we can use Hadoop's MapReduce. We can't as well because Tej is having the MapReduce itself within it. Okay, so that's why Tej is putting over here. Just like Mesos, Spark, HBase. Those three things is having MapReduce as well as Yarn inside itself. They're only taking HDFS from Hadoop. Okay, so that is why the building blocks is created in this way by this hierarchical structure. That means which technology is taking which particular part or which particular basic building block it's taking from Hadoop, and the rest of the thing is with them. There is several kind of things, just like Oozie. Oozie is a scheduler. I mean, whatever job we are designing over there, we can schedule the job by Oozie. There is Zookeeper. Zookeeper, as per the pictorial diagram over here, you can see it's checking. I will tell you what is Zookeeper quickly in the later session. So basically, it's checking whether we are assigning proper resources. Resources mean not the man over here. Resources mean when we will be doing this kind of MapReduce and all, that thing should be done by the task node or data node. And that should be controlled by name node. I'll be coming to this slide quickly. And Zookeeper will help us to check or to watch the process, whether the name node is up. If there is any issue with the name node, then it will help to report it to correct component. Okay. On top of everything, you can see Apache Ambari. This is an also a API, a good user interface by which it's a portal kind of thing. We can log into this Hadoop ecosystem and we can check everything in a folder structure there. which job is currently running. We can check it over there. So it's just like a user interface. Whatever we are checking over here, we are doing some operation on top of HDFS yarn. We can see the same thing in the user interface or a graphical or we can say portal format, and that is called Apache Ambari. This is another component. Okay, it's on top of this. No other operation should be there. It's just for visualization purpose. We also can modify something or control the thing, control the resources part from Ambari as well. Okay, so those are the entire stuffs are called Hadoop ecosystem. So today we can learn the basic of the Hadoop building blocks, that is HDFS, Yarn and MapReduce especially. And tomorrow we can pick up one of the components, especially Spark. We can cover Spark because I have some knowledge on Spark, or I have the experience on Spark, and how to cover up Spark and how we can code on top of Spark. That thing we can cover in tomorrow's session. Today, to introduce you the basic building blocks, I'll be covering these three components now. Okay, so first, okay, 2-3 more points. From the Hadoop ecosystem, we have the proper interface to connect with external data storage as well. So there is lots of external data storage. Just to we know we are out that MySQL, Cassandra database, lots of other things as well. I did not mention everything. MongoDB, it's a NoSQL database. So we can have the proper API interface that we can connect with, just like with Scoop, with Spark, we can quickly connect the external databases as well. Okay, with using proper libraries and all, what we have learned at the Python side. So it's possible over there. And there is also some query engines available, just like Hue, Presto. Query engines means we can, whatever I was telling earlier, just in P or in Hive, we can do SQL query. So this is the, we have Hue, Presto, those query engines are available. That's why the interface, we are installing the particular MySQL to get our query engine and all. But over there, this kind of query engines are available, so that on top of this query engine, we can open Hive and do our queries. Okay, so this is the concept of query engine. Those are also the features of Hadoop. Any doubt? Maybe today's classes is a bit a different one. This is a theoretical one we are covering as of now on top of Hadoop. But the basic things you need to know before digging in dive or with more detailing part and all. So if there is anything, please ask me. Okay, I hope no. So those query engines are available. If we choose any of the query engine, based on that, we can do queries maybe on Hive, maybe on Spark and all. Okay. By the way, Spark is having its own query engine as well. It's not available, just like Hive. If we are doing Hive, so if we try to having a query engine, then we can use Hue. Hue is a portal-based query engine. We can open the portal of Hue. We can logging into it, and on top of that, we can do Hive queries. Sorry. Okay. Now we are inside the core of the Hadoop. That I told you, the basic building block was on top of HDFS. On top of that, we have Yarn, and on top of that, we have MapReduce. Those are the things which are doing the distributed data. Especially the MapReduce. HDFS is distributed file system, which is distributing the storage. Okay, distributing the storage by HDFS. Suppose you have a big file, we need to split the file in a small chunks of file. Then we can store it into multiple computers. That is called, that is the action item of HDFS. Hadoop Distributed File System. That is the full form of HDFS. Then Yarn. Yarn is yet another resource negotiator. So Uh, Actually, the Hadoop ecosystem, it's consisting lots of resources, means lots of computer. Okay. Earlier, maybe when we were learning EMR clusters in one of the AWS component, I was telling you that time we need to spin up lots of EC2 server inside a single component. That single component is called EMR, Elastic Map Reduce, and inside that lots of EC2 server can be launched. Each of the EC2 server will be playing their role. Maybe one EC2 server is name node, maybe other uh, EC2 servers are data node or called task nodes. Okay, but for a particular calculation or for a particular processing system, whether we could require a new resource or whether we can omit the resource from this system, that can be controlled by yarn. Okay, that is called yet another resource negotiator. Resource mean not a people over here, it's the particular computer or cluster which will be taking part in the calculation in the distributing system. That should be controlled by yarn. Okay, and map reduce, it's the main thing, the main fundamental thing, and we are using computational power which should be distributed in nature, should be done by map reduce. Okay, we are mapping the thing and then we are reducing the thing. So this is the main thing. What is map and reduce? We have a pictorial diagram in the next slides. I hope by watching this that should be understandable. Okay, moving to the next slide. Yes, so Hadoop means, HDFS is Hadoop Distributed File System. So what I told you, breaking large file into blocks and distribute storage of big data across our, that is how we are doing this thing for HDFS. We have lots of computers which can be connected by a LAN cable and all to set up our big data things. Okay, the hardware part should be controlled by another vendor or just like this. We have the hardware setup amongst us. Maybe in our machine itself, in a single machine, we have multiple CPUs, multiple cores over there. So each of the cores, we can distribute the thing. Okay. So distribute the storage of big data across our cluster of computers. In a single cluster, there should be multiple computers. We can distribute the file system or files between them. The architecture of Hadoop has been done in this way. As a developer part, we do not need to check this thing, and even we do not have this visibility or scope to check how the this thing is getting handled, how the file is getting distributed. That should not be our scope. That we can check. Maybe in process we are assigning 2 or 3 resources from our side for processing, but we can check the particular process is still high. Then that should be a fault of HDFS or the particular Hadoop architecture and all. It's a inbuilt feature over there, so no need to do from our side. Rather, we can develop our code and we can check whether all the nodes are running fine or not. Or we have, imposed for 5 or 6 nodes, but we are checking 2 nodes are running. Maybe we need to check our job then. If the job is fine, then something issue with the particular system. We need to reach out the system provider of Hadoop. Why all the resources are not working? Why Yarn is not checking that we are requesting for 6 resources, 6 data nodes, but they're only assigning 2 nodes. So this kind of thing we can check first. Then we need to reach out particular support team for that one. So they have the architecture with them. Okay, we do not have to get worried if we are just going ahead with the data engineer or data developer and we are working Hadoop as a system. Okay, Yarn I already told, yet another resource negotiator. It manages the resources on computing clusters. Okay, that is Yarn. Okay, so first of all, how the HDFS architecture is there, I just took some screenshots from web. So, to understand you, how the things are working. So there should be a single name node. Name node should be checking the data. Where we are storing the data. Even name node needs to track where the data node is located. Each of the data node means each of the server. Okay, they need to remember the IPs of each of the data node. So while sending instruction, we need to send them with the IP addresses and all. So name node should be having one IP, and data node should be having another IPs. And name node will be keeping track of each of the data node. And even if we are storing the things in data nodes, there is a big file or big data. We are breaking into small chunks and we are storing into each of the data node. But there is also the mechanism is such like that if a data node is having some issue, or maybe one of the data node means one of the server was suddenly shut down, or maybe some issue or some faulty experience, or maybe one of the data node got damaged. So we have that particular fault tolerance, or just like I want to say that particular copy which are been stored in this data node, the first data node, that was been distributed of some other data nodes as well as per the disaster recovery process. So it is having that mechanism that a single copy. I told earlier that we are dividing the big file into small chunks of files, and we are storing each of the chunk files in each of the data node. But those kind of thing we are storing not only one system, it is also spread across the system. That's why if we lost one file or one small chunk of file from a particular data node, that can be easily fetched from other data node as well. Okay, so this kind of mechanism is there in our HDFS architecture. But name node is controlling everything. It's just like a metadata storage over here. It's storing everything. It's not storing the data itself, but it can store the information of this data nodes so that it can control everything. Just like I told you, a single name node keep track of multiple data node. It's tracking what they're doing. What particular duplication of a particular small chunk is present with another data node. So it's checking that thing. Each of the data node having their own thing as well as some duplication of any other node's part as well. The storage part, I tried to say. So suppose we have an external client which wants to read a particular file. So it will come to name node first. It will take information from name node, which that file is which kind where the file is located. Then client node will check with the data node as well to read that particular file. Where it's located, it get the information from name node and it will be checking from here only. Okay. So the same way we can write as well. Writing a particular file, client, and another node which is not inside the big data component, they want to write something in some file. They will connect with the data node and write the file and update the same to name node. Okay. So this kind of process can be done, and the architecture is already been situated over there to handle this kind of scenarios. Reading a file, writing a file, thing. That should not be controlled by us as a developer. Okay. Everything is there inside that particular architecture. They have the interfaces, the internal language to set up the Hadoop itself. So everything is there. It's a big thing they have developed. Who have developed this Hadoop? Apache is owning this thing. So particular controlling everything, to store everything over there, to control the copies for the disaster recovery, to write the file. And also, if we are writing the file in that data node, the first data node, it should be also copied into this net data node based on the disaster recovery algorithm over there. So they are keeping themselves, which particular, maybe there are hundreds of nodes, but we are copying of this thing for some nodes only. Even for this third nodes, we are copying to another 5 nodes just for disaster recovery. So that kind of algorithm is also present there. So everything is done by the internal setup of Hadoop. We can control the things on the user interface level. We can develop a particular SQL query, but the SQL query will take huge time. So that SQL query, based on the SQL query or based on a particular thing, suppose we are doing some, expensive operation on top of Hadoop, SQL operation. So the expensive one we can do, it should not be processing as well. It should not be, sorry, distributed in nature as well. But whichever is taking much more time, it's not expensive. That we can distribute over the clusters, that particular computational thing. Based on the data volume, based on the particular timing it's taking while fetching the data by a SQL query, we can control our SQL query there. Or we can write such a program that which kind of SQL query needs to be distributed in nature and which kind of query should not be distributed in nature. So that kind of program, we just need to know some of the programming language we should be working on top of Hadoop, and that is sufficient as of now. The architectural part, as a developer of the data engineer, we should not uh, we should not have to check it from our side. There is different team who will be supporting that Hadoop. They will be checking that from their side, the admin team as well. But we need to know how this is working. Okay. Okay. So now the question is name node. I was telling name node is taking the metadata information of every data nodes and all. Now, who is taking care of this name node? Suppose some particular any issue happens with name node as well. So uh, that is the thing. Name node is writes to local disk. Okay. So especially NFS is another thing which should be highly available, and it should be much more secured. And for the name node, that kind of storage spaces is very much costly. So that there will be no issue with that one. Okay, so local disk and NFS, we are storing the information of name nodes as well as a backupping part. Okay, so HDFS, those are the particular thing. I told you Ambari, Apache Ambari is one of the thing we can check what we are storing in HDFS. Suppose we need to store a particular file. Okay, so we can use some interfaces just like PuTTY for Linux environment. It's a command line interface, as well as we can use the drive kind of. We can create a folder over there and everything that can be controlled by Apache Ambari. It's a particular portal only, but inside the portal, everything should be maintained as the folder structure or the directory structure. Over there, we can store any files. Okay, and the same thing can be controlled from PuTTY. If it's a Linux server, then we can just log into there and we can store the thing. Just like make directory, remove directory, you store the things over there as well. So we can, those are the user interface, different user interface. NFS gateway is there, Java interface are there. So those are different interface to check HDFS system. Okay. So as of now, as we are doing this thing, maybe this particular session we cannot show you the thing. Maybe next session, if you can join for only Hadoop session, we can show you. We can install Apache Ambari. I'm trying to install something for Hadoop, the entire package of the Hadoop. Then Apache Ambari should be a default one we can get, and we can show you how it works, how it look like. Okay. So these are the system, just to let you know. Okay. Now this topic is for MapReduce, the topmost one in the Hadoop basic building block. So what we are receiving at the big data input, those are the splitted in version. Those are the distributed in version. So the transformation we are doing this map operation. So mapper, there is two kind of tool, mapper or reducer. Mappers will be transforming each of the thing, which will be distributing in nature. So we have multiple mappers over here, and that can be done obviously by some machines as well. So you can split the data, the mapper thing should be there. And when we'll be reducing means we can aggregating the thing. Okay. So we can aggregate the thing and store our output over there in a single system. So those kind of map and reduce can be distributed in nature, which should be helping us to do the calculation very quickly. As per the normal one, that thing should be much more faster because the calculation should be distributed in nature in this manner. So how map reduce? What is map? Mapper transform the data across computing clusters that I told are, and the reduces, what it should do, it should aggregate the data. Just like we have found some of the aggregation function in our earlier classes, just like group by. Okay, if we do the group by, then we can see, suppose we have we learned that we have multiple line items in a particular table. If we are grouping them top of one particular columns, then inside the columns, what are the different data? We can group the other data on top of that one. So we are reducing the data lines over there. Rather, we are grouping this thing. That is the operation of reducers. Okay. So reducer will be working in this way. Especially Hadoop, it should be going ahead with this kind of aggregation functions only. Then, this kind of reducers is working in this way. Okay. So I think we have almost complete for this thing till today's session. Any doubt from anyone what we learned today? Okay, hopefully no. Let me quickly show you one more thing. Actually, we have completed the thing for the basic one. Tomorrow I'll be picking up Spark with some detail level, some more API level. For Spark, we'll be using Spark on top of HDFS. I'll be taking, we can only take HDFS from Hadoop, and MapReduce and Earn is already there in Spark. That's why the picture is over here. And we can check what is processing inside the Spark by Apache MBody. Okay, we can install any other intermediate particular component from here as well for external calculation. We are processing some data, but to store the output data, we can store it in a Hive database. Okay, or we can use some external databases as well. So this kind of, external things we can also install. But for Spark, we can specially concentrate on Spark. What are the different APIs that are available over there? What are the different data storage components are there in Spark that we can quickly learn. But to use Spark,
I have one doubt.
yeah, sure.
Hadoop, how many types of data sets it can handle? Like, is there any particular restrictions?
Yeah, of course. When we'll be using Spark, actually, we can see. I'll be covering this thing tomorrow. So
No,
inside.
like types of data types.
Okay, data types.
Like
You
what
are
are the,
you mean
yeah,
you
what
are
are the
meaning
data
that
types like Hadoop can handle?
integer, float, or this kind of stuffs?
Yeah.
Yeah.
Yes.
So yeah. Okay. So data types, it should be as simple as just like let me show you that data types is top up on the language we'll be working. So just like Spark, when we'll be using Spark tomorrow, I'll be showing this particular topic that we can use that Spark on top of particular language like Python, like R. So if you're using Python on top of Spark, that is called PySpark. Okay. So whatever data types are available in Python, the same kind of data types we can use in Spark as well.
Okay.
Okay.
Yeah.
So Spark can be handled by four languages.
Yeah. What about the data sets? Like
Yeah,
the
data
types of
sets.
data sets which could be
Those
handled
are
by
the
Hadoop.
those are the different APIs available. We can use RDD. We can use data frame, data sets. Those are the different kind of storage. Storaging of the particular internal storage of data, rather we can say. So
Like structured.
yeah, those are structured in nature. So there are also some external thing I told you to store the NoSQL database, just like MongoDB. But for over here in Spark or in Page or Hive, we can store in structural way. It should be relational database. Okay. Even we can store also non-relational database, but specifically the efficient way of storaging of non-relational database, we should have to use the external one, just like MongoDB. for this particular storing purpose, but especially we are working on top of data frame or data sets over here, which is relational or structural database. Okay. And the particular data types that I shared that I was telling, if we are using Python on top of Spark, that is called PySpark. Whatever data type is available in Python, that should be controlled over there. If we can use the Java language over there, then the Java data type we can handle by Spark. Okay. So four kind of actual languages are available, just like Python, Scala. Scala is one of the language. Java is third language, and R. I think you have also heard about R. So that's totally language specific over there. Okay. Yeah. So tomorrow some more detailing level on top of Spark, then that concept should be clear. And but definitely we do not have the hands-on thing over here as the system or the architecture we do not have. You need to install Hadoop. Just like for Spark, if we want to install, Spark, before that we need to install Hadoop. So each of the Hadoop's release version, some Spark release version is also there. So if you want to install Spark recent version, what recent version of Hadoop needs to be installed, you need to take care of that thing as well. So tomorrow I'll be covering up this thing again, and we can connect on that one. Okay. Any other doubt from anyone? Okay. So I hope nothing. So let's connect tomorrow with Spark, the basic of the Spark. So tomorrow should be the end session for Hadoop. And 1 day is left. If we have some hands-on, okay, I have given you some example or exercise for Python, so that we can cover up in the last day of, if there is any doubt on data, or if you have any questions, or if you have any career oriented questions, you can quickly discuss. It should be very small session for the last day. That means the Friday. So this is the plan, and we can close up this particular season on Friday. Okay. So let's connect tomorrow with some more external, internal thing on top of Spark. Okay. Thanks. Thanks everyone. Bye bye.